Hello students, myself Milan Patel, Assistant Professor at LJIET Institute of Engineering and Technology. Today's topic is Civil Engineering Materials. In today's lecture, we will cover two important materials in construction. First is concrete and second is brick. So without wasting much time, let's begin with concrete. In concrete, first we will discuss what is concrete. Second, various ingredients of concrete. Third, various types of concretes. And lastly, we will cover grade of concrete. Let's start with what is concrete. It is plastic material of binding materials like cement or lime with sand and aggregate in the presence of water. So it's a mixture of cement, sand, aggregate and water. Okay. Mixture when allowed to set becomes a hard as stone. Other materials called admixtures are also added to obtain specific effect like rapid hardening or you can say quick setting. Okay, these are the various properties obtained by adding admixtures into the concrete. Okay, by adjusting proportion of various ingredients, compressive strength required for different purpose can be produced. Okay, it can be used in gravity dams, roads, foundation or main components of the buildings. Okay, that's all about concrete. Now let's discuss ingredients of concrete. The first ingredient of concrete is cement or some binding material like cement or lime. Second is coarse aggregate. Generally gravels are used. Third is fine aggregate in which sand is used and water. In some time admixtures is also added in the mixture for concrete. Okay, this is how concrete can be made. Okay, sand, cement and gravel first mix, then water and admixtures is added and makes the concrete. That's all about ingredients of concrete. Now let's discuss various types of concrete. First type of concrete is lime concrete, in which main ingredient is lime. Okay, lime is used as a binding material in concrete. Okay, a concrete made from mixture of lime, sand and gravel is said to be a lime concrete. You can clearly see lime powder which is in white color. Okay, this is a lime concrete example. Okay, it was widely used before the lime was replaced by Portland cement. After manufacturing of this Portland cement, this lime concrete becomes obsolete. Okay. Second is cement concrete. Cement concrete is a type of concrete mix in which we use cement as a binding material. In lime concrete, we use lime as a binding material. In cement concrete, we use cement as a binding material. Okay, this cement may be ordinary Portland cement or maybe some special type of cement like high alumina cement, rapid hardening cement, which we have discussed in the first lecture of this chapter. Okay. The properties of cement concrete is it has high compressive strength, it can be molded in any designated shape in the construction, it has higher abrasion resistance, okay, it is very strong in tension also, it can be prepared at any time, any place with the help of locally available materials, it has good appearance and finish, okay. Fresh concrete have good workability also, you can easily convert into number of shapes. Okay, it is economical material for construction. Okay, and hardened concrete have good durability or long-lasting ability and capacity to withstand all forces acting on it. Okay, these are the various properties of cement concrete. The third type of concrete is reinforced cement concrete. It's generally used to make beams, column, foundation, slabs, etc. Okay, you can clearly see this is a reinforced cement concrete. When steel provided in cement concrete, it becomes reinforced cement concrete. Okay, so reinforcement in terms of steel is provided. Concrete is having lesser tensile strength compared to other materials. To counteract this, steel is added having high tensile capacity and bond strength, okay, compared to others. and it also provides strong bond with the concrete. Okay, that's all about reinforced cement concrete. Now let's discuss the fourth type of concrete, which is pre-stressed cement concrete. This pre-stressed cement concrete is a form of concrete used in construction of long beams or girders in bridges. Okay, it is substantially pre-stressed during production in a manner that strengthens it against tensile forces which will exist when in service form. Okay, by this figure you can easily understand the pre-stressed cement concrete. Okay, in pre-stressed cement concrete, number of strands or wires are provided. These wires are then stretched with the help of jacks so that tensioning in the beam is occurred. Okay, when some load is acting on it in future, it increases the compression force in the beam. Okay, because of already tension phase, okay, its capacity to retain the compression force is increased. Okay, that's why pre-stressed cement concrete is having larger compressive strength compared to the normal cement concrete component. Okay, it is also having lesser thickness compared to the normal concrete. Okay, let's discuss pre-stressed cement concrete with the help of some example. Okay, here one wooden barrel is there. Okay, surrounding this wooden barrel some metal bands are attached like this. Okay, the metal bands induce a state of initial hoop compression to counteract the hoop tension caused by filling the liquid in the barrels. That's all about pre-stressed cement concrete. Now let's discuss fifth type of concrete, which is lightweight concrete. Okay, for that generally porous aggregate are most commonly used in lightweight concrete. It has a density in the order of 1440 to 1840 kilogram per meter cube. Okay, the general cement concrete have density about 2400 kilogram per meter cube. Okay, that's why it is lightweight. Next is high density concrete. The high density concrete is a concrete having a density in the range of 6000 to 6400 kilogram per meter cube. It is also known as heavyweight concrete. It is mainly used for the purpose of radiation, shielding, for counterweights and other uses where high density is required. Okay, it is generally used in nuclear power plant or some laboratories, etc. Okay, that's all about high density concrete. And the last type of concrete is precast concrete. Okay, these are the precast components. Precast concrete is the form of concrete that is prepared, cast and cured off-site in some industries. Okay, usually in controlled factory environment. Okay, using reusable molds. Okay, precast concrete elements can be joined to other elements to form a complete structure like this. Okay, it is typically used for structural components such as wall panels, beams, columns, floors, staircase, pipes, tunnels, stairs, okay, doors, windows. Okay, that's all about precast concrete. Okay, these are the 7 types of concrete. Now let's discuss the grade of concrete. These are the various grades of concrete. Okay, here M5 to M45 grade is given. Okay, the grade of concrete denotes the strength required for construction. Okay, for example, M30 grade signifies that compressive strength required for construction is 30 megapascal or 30 Newton per mm square. Okay, the first letter in grade M is the mix, and 30 or any number 5 to 45 or 100 is the compressive strength of that concrete at 28 days in Newton per mm square or in megapascal. Okay, this is a grade of concrete. Okay, for preparing these various grades, okay, some mixed ratio is given in this table. For preparing M5 concrete, we have to mix 1 part of cement, 5 part of fine aggregate like sand, and 10 part of coarse aggregate like aggregates or gravels. Okay, to prepare M25 concrete, we have to add cement 1 part, sand 1 part, and 2 part of aggregates. Okay, for preparing the concrete above M25 grade, we have to use various Indian standard codes. Okay, that's all about the concrete. Now let's discuss brick. This is the second topic in today's lecture. Okay, in brick, first we will discuss what is brick, manufacturing process of brick, composition of good brick earth, types of bricks, and classification of bricks. Let's start with what is brick. You all have seen brick in your life. Okay, bricks are one of the oldest and most popular building material in civil engineering. The reasons for bricks being very popular and widely used construction material are: it is very cheap compared to other materials, it is durable, it is easy to handle and work with, it is easily available, and it is lightweight. Okay, brick can be defined as the blocks of tempered clay molded to suitable shapes and sizes while it is still in plastic condition, dried in the sun and burnt if desired, so as to make them more strong, hard and durable. This is the definition of the brick. Okay. Now let's discuss manufacturing of brick, in which four processes are there. First is preparation of clay, second is molding, third is drying, and fourth is burning. Okay, first is preparation of clay. Okay, in which first step is unsoiling. Okay, in which top layer of 20 centimeter depth is removed as it contains impurities in the soil. Okay, second is digging. Clay dug out from ground is spread on level ground about 60 centimeter to 120 centimeter depths. Okay, third step is cleaning. Stones, pebbles, vegetative matter, etc. are removed. Okay, this is the third step. Fourth is weathering. This clay is exposed to atmosphere from few weeks to full season. Okay, then next is blending. Clay is made loose and any ingredient to be added and turning it up and down in vertical direction. Okay, this is called as blending. Okay, or mixing you can say. And the last step in preparation of clay is tempering. Water is added to the clay and whole mass is pressed under the feet of men or cattle for large scale. Okay, these are the various steps in preparation of clay. Second step in manufacturing process of brick is molding. This molding is of two types: hand molding and machine molding. First we will discuss hand molding. Okay, in which molding is done by the hand of the persons. Okay, this hand molding is of two types: ground molding and table molding. In ground molding, this molding process is carried out at the ground. Okay, and in table molding, it is carried out on the table. Okay, so the finished work in ground molding is comparatively lesser compared to the table molding. Okay, in machine molding, there are also two types of machines: plastic clay machines and dry clay machines. Okay, in plastic clay machines is generally used for plastic clay or having water in the clay. Okay, or dry clay machine is generally used for using dry clay for making the bricks. Okay, that's all about molding process. Third process in manufacturing of brick is drying. After molding process, the brick contains some amount of moisture in it, so drying is to be done, otherwise they may crack while burning. The drying of raw bricks is done by natural process like this. We have to lay all bricks after molding in some open spaces for natural drying. Okay, the period of drying may be 3 to 10 days. It also depends upon the weather conditions. Okay, that's all about drying. After drying, burning is provided. Okay, for that various burners are like this. In the process of burning, dried bricks are burned either in clamps in small scale or in kilns or larger scale up to certain degree temperature. In this stage, the bricks will gain hardness and strength. So it is important stage in manufacturing of bricks. Okay, the temperature required for burning is about 1100 degrees centigrade. If they burn beyond this limit, they will be brittle and easy to break. If they burn under this temperature, they will not gain full strength. Okay, and there is a chances of absorb moisture from the atmosphere. Okay, so you have to burn at a particular degree centigrade. Okay, hence burning should be done properly to meet the requirements of good brick. Okay, these are the 4 steps of manufacturing of brick. Now let's discuss the composition of good brick earth. It should have alumina about 20 to 30%. This alumina imparts the property of plasticity to the earth. And excess of alumina causes shrinkage problems. So you have to maintain the alumina content 20 to 30%. Okay. Silica content in the brick earth should be maintained about 50 to 60%. The cracking, shrinking and warping of raw bricks are being prevented by the presence of silica. Okay. Lime content of this brick earth should not exceed 5% because lime prevents the shrinkage of raw brick. Okay. Oxide of iron should be about 5 to 6%. It imparts red color to the bricks. Okay. So red color of the brick is because of the iron oxides. Okay. Magnesium should be of small quantity in brick earth because it imparts yellow tint to the brick and decreases shrinkage. Okay. Excess amount of magnesium leads to decay of bricks. Okay. These are the 5 composition of good brick earth. Okay. Now let's discuss types of bricks. There are mainly 2 types of brick, traditional brick and modular bricks. First we will discuss traditional brick. Okay, these bricks have not been standardized in size. The sizes are changed according to location. Okay, the length of this traditional brick is about 20 to 25 centimeter. Okay, width of this brick is about 10 to 13 centimeter and height is about 5 to 10 centimeter. Okay, the commonly adopted size of conventional or traditional brick is 23 centimeter by 11.4 or 11.5 centimeter by 7.6 or 7.5 centimeter. Okay, this is the traditional conventional brick. Okay, second is modular brick. Okay, Bureau of Indian Standard Institution BIS has suggested uniform brick size. Okay, the size of actual brick according to BIS is 19 centimeter in its length, 9 centimeter in its width and 9 centimeter in its thickness. Okay, after adding mortar layer, the size of this brick is 20 centimeter by 10 centimeter by 10 centimeter. Okay, it is having one frog on the top of the brick having size 6 centimeter by 4 centimeter by 2 centimeter. Okay, this is the frog which is exactly at the top of the brick. This is one small depression created at the top of the brick. Okay, that's all about the types of brick. Now let's discuss the classification of bricks. First type of brick is first class brick or grade A type of bricks. Okay, this is a figure of first class brick. Okay, this is the work done with the help of first class brick. Okay, it is table molded brick. It is well burnt in kilns. It is having regular shape and size 19 centimeter, 9 centimeter by 9 centimeter. It has good uniform bright brick red color. Okay, it is free from cracks. It is sharp and straight edges. It has uniform texture. No impression can be possible by fingernail on this type of brick. The fracture surface of the brick should not show lumps of the line in this type of bricks. Metallic ringing sound should come when 2 bricks are stuck against each other. Okay, water absorption should be 12 to 15% of its dry weight when this brick immersed in the water for 24 hours. Okay, so increment in weight is about 12 to 15%. Okay, so water absorption is very less compared to other types of brick. Okay, the crushing strength of the brick should not be less than 10 Newton per mm square. Okay, the uses of this first class brick is for pointing work, exposed face work where mortar layer or plastering is not done. Okay, for flooring and for reinforced brick work. Okay, first class type of brick is used. Second type of brick is second class brick or grade B type of bricks. Grade type B type of bricks is generally used for residential type of buildings. Okay, this type of brick is ground molded bricks because of molding is occurred on the ground, the finishing is very rough. Okay, it is burnt in kilns, slightly irregular in shape and size compared to first class brick. Okay, it has irregular color. Okay, it has some hair cracks on it. Okay, not so sharp and straight edges as compared to first class bricks. It also creates metallic ringing sound when two bricks are stuck together. Okay, water absorption is slightly more compared to first class bricks, is about 16 to 20% of its dry weight when it is immersed into the water for 24 hours. Okay, the crushing strength is comparatively less than first class bricks. It is about 7 Newton per mm square. Okay, all important and unimportant hidden masonry works. What is hidden masonry works? Where plastering is done after brick masonry. Okay, these second class bricks are used. Okay, third is third class bricks or grade C type of bricks. It looks like this. Okay, these types of bricks are ground molded bricks. So the finishing of these bricks is rough compared to first class brick. Okay, these types of bricks are burnt in clamps, not in kilns. Okay, these are the underburnt bricks because of burnt in clamps. Okay, these types of bricks has reddish yellow color. Okay, it has irregular size, shape and finishing. Okay, it has dull sound when two bricks stuck together, not giving metallic ringing sound. Okay, it has distorted edges. You can clearly see in this figure also. Okay, the water absorption is comparatively more compared to first class brick and second class brick. Is about 25% of its dry weight. Okay, it is mainly used for building unimportant and for temporary structures. Okay, that's all about third class brick. Now let's see fourth class bricks. These are the fourth class bricks. Okay, it is generally overburnt bricks. Okay, badly distorted in size and shapes. Okay, dark red color bricks. These bricks have black spots on the surface of the earth. Okay, this is brittle in nature because of overburning. Okay, these bricks are generally used as ballast or as metal or as aggregate in foundation, floors and in road construction. Okay, that's all about the classification of bricks. That's all about the bricks. Okay, I hope you all understand these two important material, concrete and brick. See you soon.